Alright, so today we're going to take a look at section 2.4, which is on solving linear inequalities. So a few important things we have to remember with rules regarding inequalities compared to equations, especially when we multiply or divide both sides of an inequality by a negative, something happens. Alright, so we'll talk about that. We'll do a little bit on the calculator when we get to linear inequalities that have absolute value. But we'll be doing, I'd say, a good part of it today by hand, without the calculator. Okay, so remember, these are your four inequality symbols. Less than or equal to, greater than or equal to. That's just a quick reminder of what those are. These are both examples of inequalities. The one on the left, that is a true inequality. 3 is less than 8. The one on the right, that's a conditional inequality. How many different answers make the one on the right true? Yeah, Nick?
If x is greater than or if x is greater than 4, so like anything more than 4.
Yeah, so anything more than 4, which means there are an infinite number of answers usually when we're solving an inequality that could make it true. Since there's an infinite number of answers, we can't write the answer as an equation, like x equals 2, x equals 5. Or if there's two answers, like x equals 6 or x equals 7. We have to write the answer as an inequality. So we won't be using an equal sign when we're writing these answers. So if you want to check if a particular number is a solution to an inequality, identical to how you do it with an equation. You plug the number in for the variable and see if you get a true statement. So if I wanted to see if x equals 1, if that's true, if that works, if I plug in 1, I get 3 times 1 is 3. 3 is greater than 12, no. So that means 1 is not a solution. If I plug in a number like 5, I'd have 3 times 5 is 15. 15 is greater than 12. So yeah, 5 is a solution. Not the only solution, but it's one of infinitely many. As Nick said, anything bigger than 4. Any question on that? Okay. So what we can have, we can take two inequalities and we can combine them together, and then what we have is a conjunction, especially if we combine them with the word and. Now you can write out an inequality the long way with the word and, just like that, and this is called a conjunction. X is greater than -1 and x is less than 3. But a lot of times when we have a conjunction, we shorten it. We can rewrite that so that we don't have the word and. It's kind of, it's still there, but we don't have to write it. And that would look like this. You can take and put the variable in the middle, put the smaller number on the left, the bigger number on the right, and what I've written down below means exactly the same thing as what I had up above. And we can kind of put a box around where each inequality is. Say x is greater than -1 is the red box. That's right here. I know it's written as -1 is less than x, but that's the same thing. It's exactly the same thing. And then this one, x is less than 3, is right there. So it combines those two inequalities into one. There's also another way you can do it. You could put x in the middle, and I could put the numbers on opposite sides. What would happen if I did that? What else would I have to change? Yeah, Caleb?
The inequality sign.
I'd have to change the inequality sign. You can do this, and this means exactly the same thing. This means x is less than 3, and x is greater than -1. Okay, I usually do it the first way I wrote down. Put the smaller number on the left, the bigger number on the right, and the inequalities point towards the smaller number. They still point towards the smaller number in the other way too, but I like to have the smaller number on the left. Any question about taking two inequalities and combining them into one? Or you might have to reverse it. Take something that's combined and split it apart into two. So basically what we're looking at here is called an interval. There's still an infinite number of answers here. Any number between -1 and 3. If you include decimals, that's infinitely many. So this is a range of numbers, and this one is strictly between -1 and 3. How do I know that I can't include the -1 or the 3? That I'm strictly between. Tim?
It's not greater than or equal to or less than or equal to.
Yeah, it doesn't have the equal to. Right? So in this case, when we say between -1 and 3, we mean between, not including the endpoints. You can have the equal to, it depends on the problem. You can also have one with an equal to and one without. Yeah, depends on the problem. So this is what we call a completely open interval. An open interval is when you do not include either end of the interval. That's an open interval. So we're going to talk about a few different terms now to describe intervals. Okay, we have what's called open intervals, closed intervals. We have bounded, and we have unbounded. So I just want to kind of clarify what those four terms mean. We're going to start with what's called bounded. Okay, a bounded interval. So a bounded interval means that you have an interval where the bounds are actual numbers. The low value is a number and the high value is a number. Can anybody think what symbol we use in an interval sometime that's not a number? We do have intervals that don't have numbers as the bound. Think of the first inequality I gave you today in the notes. That would be an example of an interval that has no, I think that one would have no upper bound to it, yeah?
Would it just be x?
So x is our variable, but what do we use sometimes in an interval that's not a number? Yeah?
Infinity?
Infinity. Okay, so if you see an infinity symbol, that's different. We're not talking about infinity symbols right now. Bounded intervals have to have a number as the low value and the high value. That's called bounded. And there really are a few different kinds of bounded intervals. You can have what's called a closed interval. Enclosed means that you can include the low value and high value in your answer. So we use a bracket to indicate that. We can have a completely open interval. And that's an example of what we had up here. You cannot include either number in your answer. What else do you think there is? You have a completely closed interval, completely open interval. As I said, there's 4 types. Yep.
An open and closed. Like one end is closed, one end's open.
Yeah, and that's the other 2, depending on which one is half open. Or if you're more pessimistic, you could say half closed. But we'll go with half open. So in the first one, it's half open on the right side is open. And the bottom one, it's half open because the left side is open. Okay, but the A and the B would both have to be numbers.
And which one's the upper bound? Is the upper bound the one with the bracket or without the bracket?
The upper bound is always on the right.
Alright.
It's always low, comma, high. So you never write a bound like this. If you wrote this, I would be very confused. You're saying you can go as low as the number 8 and as high as the number 2. Yeah, that would be confusing. Another way to say that is pick a number that's bigger than 8 and less than 2. Can't do that. All right, so you always have to put the low value first, then the high value. So page 99, I think what they do is they show these as pictures. Okay, I'll do this one right here. Let's say this was A and this was B. If you were graphing it, it would look like this. If you were graphing this one, it would look something like this. You always end up shading between. That's how bounded intervals work. There's a definite end to where you shade. It doesn't shade in one direction forever with an arrow. It's a different kind of interval, which you can probably guess the name of. But right now we're talking about bounded. So unbounded is when you have an infinity symbol. An unbounded interval goes on forever. So when you graph or you shade something like that on a number line, you would have an arrow indicating that it just keeps going. And these are all examples of unbounded intervals. Okay, the first one, this one, let's number them. So interval number 1, that's unbounded because it has the infinity on the left. And it's what we would call a half-open unbounded interval. The one on the right is also half-open and unbounded. That's number 2. Number 3 is unbounded, and it's completely open. It's an open, unbounded interval. And number 4 is also an open, unbounded interval. Yes?
Or do parentheses always have a parenthesis over a bracket?
Can you say that again?
Will infinity ever have a bracket?
No.
Okay.
No, infinity always has a parenthesis, because a bracket means bracket means that whatever value is next to it is a number you can reach. Infinity is not a number you can reach. Yep.
So now we can do it. Nick said like the 8 and 2, like 8 to negative infinity and 2, or not 8 to infinity and
Well, it's always got to be low, comma, high.
right.
Whenever you write an interval, it always has to be the low value on the left and the high value on the right. So what were you thinking?
Like we can do is like we can say 8 to infinity and negative and 2 to negative infinity.
Can you say it again? 8 up to...
Infinity
That's fine.
and then
And then you could open or closed.
infinity.
And then what?
2 to negative infinity.
No. You can't do 2 to negative infinity.
2, yeah.
Because now you're saying that 2 is lower than negative infinity. You could do negative infinity, comma 2.
Right.
You know, you could do it like this.
Yeah, that makes sense.
And something like that would mean negative infinity up to 2. Another way to say this is less than or equal to 2. That's what this means. All values less than or equal to 2. This means all values greater than 8. That's what that one would mean. So could you have, let's think about this. Could you have a completely closed, unbounded interval? Is that possible? No. Because unbounded means it has infinity, and if it has infinity, it automatically means you have a parenthesis, which makes it open. So unbounded intervals have to either be fully open or half open, at least. They cannot be fully closed. That wouldn't make sense. And they show graphs of these on page 100, but as an example of, say, number 3, if you were graphing that, it would look like this. Let's go 0, 3. You could do open circle, or I'll stick with parenthesis. That's what number 3 would look like. Parenthesis on 3, shade left. Okay, any question on that? All right. So let's see if we can write an inequality that represents this interval. So this is interval notation. I'm asking for an inequality. Hey, anyone think they could give me an inequality that represents that? Nick?
x is greater than -3 and less than or equal to 5.
X is greater than -3, and, what did you say?
Less than or equal to -5 or 5.
Like that?
Get rid of equal to 100,000.
Yes. Okay. So X is greater than -3, and X is less than or equal to 5. That's perfectly fine. Yep, that works. Can anybody combine that into a single inequality and just tell me how to write it that way? Yep. Mabel?
-3 is less than x, and x is greater than, or less than or equal to 5.
Yes. That's exactly the same thing. Right? So that means all numbers between -3 and 5, you can include 5 in your answer, but you cannot include -3. Michael?
How would you prefer it? With the and or without the and?
If the directions on the problem don't say, either one is fine. If the problem specifically says to condense your conjunction into a single statement, then you'd have to write it this way if I was testing to see if you knew how to do that. But if the directions don't say, either one is fine. How about this one? Half open interval and unbounded. How would we write that as an inequality? Caleb?
Would it just be x is greater than or equal to -4?
Yeah. X is greater than or equal to -4. Now, some people, when they do that one, they say, well, x is greater than or equal to -4 and x is less than infinity. Well, everything's less than infinity. So you don't have to say x is less than infinity. Right? You can just say x is greater than or equal to -4. Right? So unbounded intervals actually are written a little bit simpler than bounded. And let's do this one. First of all, what kind of interval is this? Bounded or unbounded?
Bounded.
Yep, bounded. Fully bounded because it has a definite number on each end. And is it open, closed, or half open? Michael?
Closed.
Closed. It's a fully closed, bounded interval. It's kind of redundant to say closed and bounded. You could just say closed, because if it's a closed interval, that means you have a bracket on each end. And if you have a bracket, you can't have an infinity. So it's automatically not unbounded. How would we write this as an inequality? Mabel?
-8 is less than or equal to x, which is less than or equal to -3.
Yep, so -8 is less than or equal to x, which is less than or equal to -3. Good. Any questions on that? Okay, so those are all examples of conjunctions. Now, let's do it a third way. So we can write something as an interval. We can write something as an inequality. We can also do a visual. Okay, we can graph it. How would I graph x is greater than or equal to 2? How about Maddie? Can you tell me how I would graph that?
A closed circle on 2,
Okay, closed circle on 2,
and then go abruptly to the right.
and then shade to the right. What else could I do besides a closed circle on 2? What symbol could I use, Tim?
Put a bracket
A bracket facing
that way.
to the right. Okay, we could do this. It's the same thing. Again, on Edge Elastic, I think the notation they stick with is the open and closed circle. So that's probably what you want to be familiar with for the test. Our book might use a combination of both. Okay. All right, let's do this one. X is less than 5. Again, on Edge Elastic, the number line would already be drawn for you. You would just be clicking on the number line where you want to put your open or closed circle, and whether you want to shade left, right, between, things like that. All right, so Leanne, how would I graph this one?
Is
it'd be an open circle or a parenthesis on 5,
Mhm.
and then it'd be shading to the left.
Yep, and then shade left. Perfect. All right. So both of these, A and B, if you wanted to describe them as intervals, what kind of intervals are both A and B? They're both unbounded because they go on forever in one direction. C is bounded, specifically half open. So let's see how we graph that. All right, so we got our number line. What kind of symbol, how about, Lindsay, what kind of symbol on -1?
Closed circle
Yep, we could do the closed circle
or bracket.
or bracket. How about, Annalise, what kind of symbol on the 3?
Open.
Open. And how about Nick, where do I shade?
In between.
This is an in-between. Bounded intervals always need to shade in between. Okay, questions on that? All right. So when we're solving inequalities, we use the same steps as when you're solving an equation, but I hinted at this earlier. What happens if you multiply or divide each side by a negative number? What do you have to do with an inequality that you don't with an equation? So,
You have to change the sign.
and when you say change it, like change it from like what do you mean change it?
Like if it's like less than, you're gonna make it greater than.
Right, you gotta like flip it, right? If it's a greater than, we make it a less than. Right, we make it point the other way. Right, so if you multiply or divide each side of an inequality by a negative, you have to flip the inequality sign. And that's just something you have to remember. It's not like if you're typing it in on a calculator, the calculator won't do it if it's facing the wrong way. Hey, it would still do it, but your answer would be wrong. Okay, so we just have to remember to flip the inequality. And sometimes, depending on how you solve it, you can kind of get away with not flipping it the way you arrange it as you solve it. But sometimes you just end up with a negative no matter what you do, and then you gotta flip it. In general, it's a good idea to write our answers this way. In this box would be the letter, and then here would be one of these 4 symbols. And then in this box would be a number. So generally we like to write it letter on the left, then the inequality symbol, then the number on the right. Okay, so how about Madison, what would be my first step to solving this inequality?
Distribute the 3 to the parentheses.
Yep. And can you tell me what I get when I do that?
3x minus 3x plus 2 is greater than or equal to 5x plus 6.
Can you say that symbol again?
Less than or equal to.
Less than or equal to. All right. So we can get into distributive property. How about Lindsay? What could I do now?
Simplify on the left side of the inequality.
Okay. When you say simplify, what are you thinking of trying to do?
Add 2 to negative 3.
Yeah, let's combine those like terms. So we're going to get 3x minus 1 is less than 5x plus 6. And how about, Michael, what would I do next?
Combine like terms.
So I don't have any other like terms on the same side to combine, but I can start moving things from one side to the other.
Yeah, that's
So-
what I meant, but
Got it. So what would you do now?
I would do minus x and minus 3x.
All right, so you said minus 3x and what else?
Minus 6.
Minus 6. All right, so we can do both at once. Minus 6 gets rid of that. Minus 3x gets rid of that. Negative 1 minus 6 is -7. Now we get a minus. Should I flip the sign? How come? But we have a negative. Yeah?
Because you subtracted.
Yeah, we subtracted, got a negative. We didn't multiply or divide by a negative. That's different. Right? So sign stays just like that. 5x minus 3x gives me 2x. Last step, divide by 2, divide by 2. And we have this. How can I write that so the variable is on the left? This doesn't involve a rule of multiplying or dividing by a negative. This is just rearranging an inequality. Yeah, Mabel?
X is greater than or equal to 7 over 2. -7 over 2.
Yep. And the reason we like to write it that way is because now if we were to graph it, that tells us which way to shade. Also, when you graph, it is helpful to have a decimal, especially if you have a fraction, you don't know what it is, then decimal is easier to find on a number line. Okay, any questions on that? Okay. So we're just kind of moving right along, hopefully nothing new today at this point. Maybe just kind of remembering a few things. Okay, so if we want to solve an inequality on the graphing calculator, there's actually two methods we can use. Method 1 involves getting a 0 on one side and calculating a root. Okay, so let's try this. All right, so method 1 involves calculating the 0, calculating the root, and then once you know where a graph is 0, it's very easy to determine the answer from there. Because if I give you a problem like this, 2x is greater than 10. Okay. And the directions here say to get 0 on one side if we're going to try to graph it. Okay, so 2x minus 10 is greater than 0. So what I would do is look for where it's exactly 0. Calculate the root. In this case, it's at 5. Then, once I know that, I either have to decide, okay, 5 is where it's equal to 0. Do I want numbers that are greater than 0? Or do I want numbers that are less than 0? This one said greater than 0. So in that case, 5 is exactly 0. I want to pick numbers bigger than 5. And that would give me numbers greater than 0. So once we know where we're 0, it's either going to be everything from that number and up, or that number and down. Okay, one of the two. So we just have to determine based on the original question, do they want to know where the graph is positive, or do they want to know where the graph is negative? Positive means greater than 0. Negative would mean less than 0. So I know a very simple one we could solve with algebra just by adding 1 and dividing by 4. So the answer here is x is less than 3/4. But the real point of this problem is to see how to do it on a calculator. Because eventually we're going to have more complicated ones. Maybe we can't solve with algebra. So we'll start with a simple one that we already know the answer to. Okay, so keep that in mind. X is less than 3/4. That's the answer. All right. So method 1 says to get 0 on one side of the inequality. How would I get 0 on one side here? What would I do, Michael?
You subtract 2 from both sides.
Okay, so I'm going to subtract 2 from both sides, and we're going to graph it. So let's type in 4x minus 3, and let's do zoom 6. Now we're looking for where that graph is less than 0. First, I'm going to calculate where it's exactly 0. Second, calc 0. So pick a point to the left, right, and do my guess. So 3/4 is kind of like the dividing line here. If you pick values on one side of 3/4, you're going to get a certain kind of answer. you're going to get positives. If you pick values less than 3/4, you're going to get negatives. So do they want to know where this graph is greater than 0 or where it's less than 0? Yeah? They want less than. Less than is in this section. That means you would have to pick x values that are less than 3/4. If you pick values that are greater than 0.75, let's say you pick 2. Well, if you pick 2, now you're going to be up there. That's not what they wanted. They didn't want it to come out greater than 0. They want the answer to come out less than 0. So any question why we picked less than versus greater than? Yeah, and that's one way to do it. Get 0 on one side and then calculate the root. The other way to do it is basically leave it alone. Leave it the way it is. Graph both sides of the inequality by putting what's on the left in y1, put what's on the right in y2. All right, let's try that. So we've got 4x minus 1. That was on the left when we started the problem. We're going to put 2 in y2. Now, if you're looking at it in terms of the colors I'm using, 4x minus 1 is blue. 2 is red. Okay, just color coding it. And what we're going to look for now is an intersect. So let's calculate the intersect and see what happens. Hit graph. And we'll do second calc intersect. Calc intersect. Pick a point on the blue, the red, and do a guess. And notice what you get. They intersect at 0.75. Now, once we know where they intersect, the answer is either going to be everything above the intersection point or everything below the intersection point. Depends what we're looking for. We're looking for where the blue graph is under the red graph. That's what less than means. Where is the blue under the red? Well, that happens. Scroll down a little. So I'm actually solving it again. It's the same problem we just did. Where is the blue graph under the red graph? That happens here. That's where the blue is under the red. So in our case, we want all the x values that are to the left of the intersection point. We want all the x values that are below 0.75. If you pick values above 0.75, like if you pick 2, you're going to be right about there. Now you've given me a value that ends up where the blue is above the red. I didn't want blue above red. I wanted blue under the red. So it's basically a different way of doing the same thing.
Oh, okay. Because all negative numbers on the left side of the y-axis.
Right, because we're looking for where the blue graph is under the red graph. So that's all the x values from basically here going that way forever. Any x value along that black line will give me an answer where the blue is under the red. So which way you do it, it's up to you. Depends if it's already equal to 0 on one side, I would probably just do it the first way. If they give it to me like this, where I don't have a 0 on one side, I would probably do a y1, a y2, and see where they cross. All right, so let's look at what happens when we have, it's kind of like a double inequality, or it's like a compound inequality. Usually when we write a compound inequality, though, we want x alone in the middle. We don't want to have something like this. So the goal with a compound or a double inequality is to isolate the variable in the middle. The difference is, instead of just having a left and a right, you have a left, right, and a middle. So whatever you do to the middle, do to the left and do to the right. Same rule still applies. If you divided by a negative, you have to flip the signs, plural, because there's two of them. So if this was a -2, and I said, okay, to solve that, we're going to divide everything by -2, both of these signs would flip. It wasn't a negative when we started, so I'll just leave it like that. So let's try an example solving a double inequality. What do you think, if I want to get x by itself, would be my first step in this one? Yeah, Abel?
Multiply by 3.
Good. Let's multiply everything by 3. When you multiply by 3 in the middle, you already had to divide by 3, so it's going to cancel. Annalise, do I need to flip any of my signs?
No,
How come?
because it's not a negative.
What's not a negative?
The 3.
The 3, multiplied by +3. So there's no reason to flip anything. So -9 is less than 2x plus 5, which is less than or equal to 15. Okay, how about Julie, what's my next step?
Subtract 5.
Yeah, subtract 5. Do it in the middle, do it on the left, do it on the right. -9 minus 5, it's going to give me -14, is less than 2x, less than or equal to 10. And Sophie, my last step?
Divide by 2.
Good. Divide by 2. Left, middle, right. Any sign flipping that needs to happen? Nope. I'm going to get a negative on the left, but I didn't divide by a negative. Okay, that's, we only divided by positive. So, final answer. X is greater than -7 and less than or equal to 5. Okay, so any questions on solving when you have a double inequality or like a compound inequality?
When would you flip the signs again?
Only if you multiply or divide by a negative.
Okay.
So like if this was a -2, everything would flip when we divide. All right, let's look at this one. Consider the set of rectangles where the length is 1 unit more than twice the width. Let's write that down as an equation first. And the important thing you want to focus on is length is 1 more than twice width. How could I write that part? Length is as an equation. Yeah, Matt? L equals. Length is 1 more than twice width. How would you write that? 1 more than twice width. Julie?
1 plus 2w.
Yeah. 1 more than twice width. All right, so that's probably going to come in handy. They didn't say we had to do that, but I bet we're going to need that at some point. So find an algebraic representation of the rectangles mentioned above that have a perimeter of less than 100. All right, so here's my rectangle. And it says, consider the set of rectangles where the length is 1 unit more than twice the width. So the length we represented as 1 plus 2w. How did we represent the width? Yep.
2w. Or,
Just W.
Just w. right? We just let the width be W. So how long is this left side? Caleb?
Just W.
W, and how about the bottom side?
1 plus 2W.
1 plus 2W. Now it says find an algebraic representation of all the rectangles with a perimeter of less than 100. So perimeter less than 100. What's my perimeter of this rectangle? Yep, Tim?
1 plus 2 W's and 2 W's
Yeah.
together.
And if you add all that up, what do you get?
You would get 2 plus 10W. No. Yes. Wait. Oh, 6W.
6W. So the perimeter here is 6W plus 2. And they said to write down an expression that represented that being less than 100. So there you go. That's an algebraic representation of all the rectangles that have a perimeter of less than 100 and meet the condition they mentioned up above. Any question on that? That's part A. All right, part B is find the possible width. So now solve that inequality. All right, so we've got 6W plus 2 less than 100. How about, Annalise, what's my first step here?
Maybe to subtract the 2,
Yep, subtract the 2. And my last step,
divide by 6.
divide by 6. So we get 16 and a third, or about 16.3. And I think that was inches. So the width has to be less than 16.3 inches. And as long as the width is under that, then it will meet the conditions that he specified in the problem. Okay, questions on that? Probably the trickiest thing there is just translating that sentence into an equation. Length is, and then we have to make it an equation. All right, absolute value. I think that's the last thing we focus on. So absolute value inequalities, very similar to solving absolute value equations. You have to split it into two problems. And just like before, you have to isolate the absolute value. So it has to be alone on one side. And the first expression is exactly the same as the rules from yesterday. Write down the same problem that they gave you, but without the absolute value bars. Now for the second one, what we did yesterday is we changed the sign of the number on the other side. We're still going to do that. But think about what happens when you change the sign of a number with an inequality, or if you divide it by a negative. What else would you have to do if you divided an inequality by a negative? Yeah.
Flip the sign.
Yeah, we'd have to flip the sign. Okay, so that's going to be the extra step. So inequality number 1, same as the original problem, take away the bars. Inequality number 2, same as the original, except take away the bars. We're going to change the sign. That's the same as yesterday, but this is the extra part. Flip the sign. All right, so we're still negating the number just like we did yesterday. But now we have to flip the sign. And there's one other thing that happens with inequalities. When you write the final answer, you have a choice of connecting the answers with the word and, which we've been using today. Does anybody know the other word that we use a lot, Michael? Or. So we have to decide, is it this and this, or this or this? And the way we decide is we go back and we look at the original problem after we've done step 1. Once you have the absolute value isolated, you've got some stuff in there, you'll have something on this side, you're going to have an inequality symbol right there. You look at that inequality symbol. If the inequality symbol is a less than or equal to, we use and. And the way I remember it, less than, land. If you remember that word, if that helps. Less than, and. And then greater than or equal to is or. You could even try to exaggerate how you pronounce it. Greater. Like greater. Greater is or. Less than, and. It kind of has the word in it. Less than. All right, so let's try one of those. Okay, first of all, is the absolute value by itself? Then we can decide right now if this is an and or an or in our final answer. Is it an and or an or? It's an and. So we should start writing the word and all the way down when we do this problem. So we're going to split it into two, and it's going to be an and. Can anybody give me the first inequality that I'm going to split this into? Yep, Nick?
X minus 3 is greater than negative 3.
Okay, so I'm going to do that one second. X minus 3 is greater than negative 3. So he did the harder one. He took the original problem, took away the bars, flipped the sign, and then made the number on the other side negative. And what about the easier one? Tim?
X minus 3 is less than 3.
Yeah. And then we solve it. X is less than 6. And X is greater than 0. But it is important you have the word and. X is less than 6 and greater than 0. Any question on that one? Yeah.
Should you rewrite it without the and just doing the?
That's okay. You could, or you can leave it like that. It doesn't matter. Obviously, if it's an or, you have to leave it. There is no way to rewrite it without the word or. But with an and, you do have that option, but they didn't say to do it, so I'll leave it. All right, let's look at this. So this is a formula that you can use if you wanted to describe something like this. I want to know all numbers that are within 3 units of 10. I want you to write me a formula that would calculate all numbers that are within 3 units of the number 10. So if we kind of change this one to match what I just said, I want you to pick a number that is within or less than 3 units from 10. If you were to write down x minus 10 is less than 3. If you solve that, it's an and just think about it in your head before we even solve it. All numbers that are within 3 units of 10. That means from 7 to 13. Those are the numbers that are within 3 units of 10. So I have x minus 10 is less than 3. X minus 10 is greater than negative 3. Solve it. X is less than 13, and x is greater than 7. So that's a formula that gives me all of the numbers that are within 3 units of the number 10. 7 to 13. That's what this formula does. Let's try this one. What if I wanted a formula that told me within 4 units of the origin? Within 4 units of the origin. And remember, this That number is kind of what you're centered around. This number is how far away from that can you go. So think about origin. What would that number be? Michael?
I have a question.
Yep.
Would that be a less than or less than or equal to?
It depends on how it's worded, but we're going to assume like within 4 means strictly within 4, not equal to 4. Yeah. So if we are within 4 units of the origin, what would B be? Yeah.
E0.
Would be 0. We don't even need that. And A is how far away you're allowed to go from that number. How far away can we go from the origin? Within how many? Within 4. So there's a formula that represents within 4 units of the origin. Any number that has an absolute value less than 4. How about within 3 units of the number 2? What number are we basing how far away we can go from? We have to be, what's our number that we're kind of centering what we have to be around? Julie?
2.
Yes, 2. That number goes there. On the other side, how far away are we allowed to go from the number 2? Yeah. 3. And if you solve that, it would give you the answer to what is less than 3 units from 2. That's easy to think about. It's -1 to 5. Those are within 3 units of 2. Now, what do you think would happen if I changed one word there and I said x is more than 3 units from 2? Could almost use the same thing. But what would happen? Yeah.
Would it be addition inside the absolute value?
So we would still want subtraction because subtraction measures how far away something is from something. Like how far is 10 from 7? You do 10 minus 7 and you get 3. So this measures how far away. So we still want to keep that as subtraction. Yep.
Would you just flip the sign?
Yeah, we would make that a greater than. That's all that would happen if it was more than. All right. So I'm going to hold off on solving that one. And let's finish up just by solving this graphically. Just make sure people know how to type this in. Actually, you know what? It's probably quicker to do it algebraically. I'll do it that way. We could do it we'll save graphically for another time. Look at what this says. It says you're dividing 2 things, and you want the answer to come out greater than 0. Well, how is the bottom always going to come out?
Positive.
The bottom is always going to be positive. Right? We can't plug in, well, what can't you plug in for x? That would be, yeah, you can't plug in 2, so pretend we're not using 2. But the bottom is always positive. So what you have is this. This is always a positive. What would the top have to be to make this inequality true? It would have to be what kind of number in the top?
Positive.
It would have to be a positive. Because the bottom is always positive. You can't mess with that. It's going to be positive no matter what you do. The top could be negative, but we want it to come out positive. So then a positive divided by a positive is greater than 0. So all you really have to worry about here is the top being greater than 0. So it might have looked like it was kind of a complicated problem, but it really isn't. You just have to make sure x is greater than -3. Don't even worry about the bottom, because that's always positive. Just make sure the top is positive, and you're good to go. All right, so homework tonight. It's just on 2.4, so there's not two separate pages, which is page 108. And 34 to 38 is even, and 60 to 62, that's also, I guess I could just do a comma then. So we'll take a look at that tomorrow, and then tomorrow we'll finish up everything for the week, and we'll have our test on Friday. My plan is to be after school tomorrow for extra help, but if you also want to stop by and you have time during another period, just send me an email and let me know.